Okay, I'm going to set up OpenStack. So the first thing we have set up are 3 VMs, a controller, a network, and a compute server called Compute1. And these are all installed under Proxmox. So they're all virtualized machines, but in a real OpenStack installation, these would be hardware, physical hardware. So the first thing we're going to do is change the networking on each of these to use manual networking instead of network manager. So we go service network manager stop. That's actually a really good sign. Service network start. So it looks like we didn't even install network manager, which is great. Okay, the network is up. We can skip right over this. The next thing is we may have something called firewall D running instead of IP tables, and that's if we're running Fedora. And let's assume that we are, even though I know we're not. We'll do service firewall D stop, and of course that's an unknown service, which is good, and we want to make sure that we're running IP tables instead. So do check config the service IP tables start, check config IP tables on. Okay, the next thing we're going to do is copy. Actually, we don't need to do that. We can just type it manually in the next window. So let's go service IP tables start, check config IP tables on, service IP tables start, check config tables on. And we go back to the controller node, and we've now enabled IP tables. Okay, so we're going to set up neutron-based networking, which is the OpenStack native networking. So the first thing we've done is the documentation is a little bit different in that we're using some actual routable IP addresses because this is going to be something we can access from the outside. The interface is the management interface is all on the 199.79.202 subnet, and that's actually a routable network. We're skipping over that for now, and that's because these are already set up and reachable from the internet. So the first thing we want to do is on the compute node, we want to verify our networking. So let's go over to, on the controller node, I want to verify our networking. So we have 4 Ethernets, and we're going to look at ETH0. We've got a whole bunch of IP addresses, and this is the important one. These are going to be blocked from our corporate firewall, so no one will actually be able to reach them outside. So that's set up that way. That's the controller node. This is the network node, and that's set up that way. This is the compute node, and that is set up that way. So those are already done. Now what we're going to do is set up ETH1 as the tunnel interface, instance tunnels, and that's so the instances can talk to each other on non-routable interfaces. So the first thing we want to do is make sure that we can reach openstack.org from each thing. So on the controller we do ping -c4, that's to send 4 packets. These are ICMP ping packets, ICMP echo, and that's of course good. And let's do the same thing on the other 2 nodes. Great. So we've now established that routing is working and DNS is working. And so now let's make sure that the controller node can ping the network and compute nodes. So we're in the controller node, ping -c4 network, good. Ping -c4 compute 1, good. And let's see, ping -c controller, oops, ping -c4 controller. Aha, I should spell it correctly. Ping -c4 compute 1, very good. And then from the compute node, we want to verify the same. Ping -c, let's do 1 packet because it's either going to pass or fail. Okay, good. 0% packet loss. Ping -c1 network. So this is analogous to a full mesh, but it's at layer 3, so I don't want to use the term full mesh, but essentially every host can reach every other host directly. So great, we've now verified internet connectivity and intranet connectivity. So the first thing, we're actually skipping over legacy networking. We're not going to set it up because what we need to do instead is set up these instance tunnels. So the first thing we want to do is create an instance subnet, and that is 10.0.1.0/24. And that's an instance network that is not routable, but all of these instances, these three hosts, will be able to talk to each other on that. And what we're going to use for simplicity is we're going to use the same third octet that we use for the existing routable interfaces. So first on the controller node, we're going to go to etc sysconfig network scripts. Oops. And you should see a bunch of stuff, ifconfig eth0. So the quickest way to create an eth1 is copy ifcfg eth0 to ifcfg eth1. Since we're not running the network manager, it's not going to automatically do anything. So then let's bring that up in VI. Let's get rid of everything that is not necessary. So we're changing this to eth1. We're going to get rid of the UUID. Nope. Get rid of this. Get rid of the hardware address. So the IP address is going to be 10.0.1.24. The gateway is going to be 10.0.1.1. DNS, we're going to leave that blank. And let's not have it be the default route. And let's call this system eth1. And actually, let's leave out a gateway for now. We can always add that later because we're only going to be talking on the instance network locally. So let's say domain is, we're going to leave that blank. Boot proto is none, and boot is yes. We know it's an Ethernet. A lot of these things are determined automatically by the system. So I'm going to say it's device eth1. It's going to start on boot with this IP address, this prefix, and let's ignore this and say that. So now let's restart networking. And what this is going to do is actually pause. You can see right here, yeah, there we go. And it doesn't output anything to the screen until the network actually comes back up because we're logged into this remotely. So now eth1 is up as well as eth0. So let's do the same thing on the other nodes. And to make matters simpler, we're going to copy this entire thing here. We're going to go to the network node, etc sysconfig, network-scripts, and let's create ifconfig-eth1. Oops, that is completely unrelated. It was from MySQL statement. Feel free to look at that. You can decipher it, tell me what it means. Okay, so this one is going to be 1.28. And so we see we still have eth0, which we know because we're still connected to the machine interactively, and so on. And so this is 10.0.1.28. And now let's go to the compute node, and we can do the same thing. Config eth1. That's interesting. That's because this machine already had 4 connectors. Okay, and since this is 199.79.202.71, we're going to change it to 10.0.1.71. Service network restart. Now the next thing we want to do, since these should all be on the same VLAN because they're all running on the same hypervisor, is we want to make sure that we can actually ping the network node, or the controller node, which is good. We can. That's from compute. Cool, we can ping the network node. Now from the network node, we should be able to ping the controller's internal network, which is 10.0.1.24. And 10.0.1. Now these are extremely rigorous tests because if you can ping in one direction, in most cases, you can ping in the other direction. There are issues with ARP caches, and especially when you cross network boundaries. That's not happening in this case, so the rigorousness is more of an exercise in good practice. So now we have set up both networks on the compute node, the network node, and the controller node for our OpenStack. So now we've actually set up, we're not setting up legacy networking, we're going to use Neutron. And so the next thing that we are going to go to is in the next section. We're on page 14 actually of the guide. We're going to skip over legacy network. Okay, the next thing we're going to do is on each node we're going to install NTP, which is Network Time Protocol. So yum install NTP. And let's do -y so that doesn't prompt us. It's going to prompt us on the other one. Cool. So we already have NTP on the controller node. It's likely we have it on the network node and the compute node. So here we are on the controller node. So the next thing we want to do is start it up. Service NTPD start. Check config NTPD on. And then on the network node, we're actually installing it on the network and compute nodes. It's already installed. So we've now, okay, so now let's go ahead and do the same thing. Check service NTPD start. Check config NTPD on. And it's actually taking its time to install it on the network node. And just to show that the order doesn't matter, that we run these two things, I will do them out of order. Okay, so now we've got NTP on each of those things. So the next thing we need to do is create a nice default password. And OpenSSL has a great tool for generating a hex string. So we're going to generate OpenSSL rand, which is for random, hex 10. And this is generating this 10-byte hex string, which is actually 20 hex digits. It's 80 bits of information, and we're going to copy that to the clipboard. Also, since I'm running screen, I'm also going to put it in the screen buffer. And if you don't use screen, it's a great tool for when you're managing an OpenStack cloud, or really any multiple system environment. So now we have a password in our buffer, and we're going to use this extensively to set up the various components of OpenStack, like Keystone, demo password, and admin password, and of course the database. So the next thing we need to do is on the controller, we need to install MySQL. So yum -y install MySQL, MySQL-server, MySQL-Python. And I'm actually going to go ahead and pause this because this could take a few minutes to install. Okay, now we've gone ahead and installed MySQL. And so the next thing we want to do is edit the my.cnf file. So etc/my.cnf. And there is we need to add the bind address. So this is under the MySQLD. Currently this is not listed, so we're going to add this bind-address equals, and we're going to add the management interface, which is the non-10.x interface. So that's 199.79.202.24. Again, these are blocked by the firewall, and most of the times these VMs are going to not even be up, so it doesn't matter that we're using routable ones. So the next thing we want to do is we want to enable a couple of different types of encoding and UTF collation. So I actually don't know a lot about these, but these are recommended by the guide. So we'll go under the MySQLD section here, and we add default storage engine equals InnoDB. And the great thing about this is you don't need to be a database expert. You just follow the guide, and it's very good, and you'll have OpenStack running. And of course, there's an entire discipline of how to protect it, secure it, and make it reliable, but that's not what this is about. This is just a cursory installation of OpenStack in a virtual environment to get a taste of what it's like. So this appears to be some MySQL code that's probably run at each time you connect to the database. So character set is UTF-8, and that is the universal, it's like a encoding format. So the next thing we want to do is start the MySQL database. Again, we're on the controller. Interestingly enough, we're still in the network scripts directory, which is not important, but let's go back to the root directory, just for simplicity. And we type service mysqld start, and it's actually creating the initial databases. That's always a good sign when it reports OK. And it's doing a little bit more. It's probably creating a table. Okay, and MySQLD is running. Now we want to make sure that it runs every time we boot. So we type checkconfig MySQLD on. And checkconfig is a wonderful tool on Linux for managing startup scripts. And if you've ever worked with Solaris, it's similar. It's this SMF, the Service Management Facility. So there we go. The next thing we need to do is set up a root password on the MySQL database. And we have to delete the anonymous users. And so that's very important, actually. Otherwise, stuff that we try to do later on won't work properly. So we run something, we haven't run MySQL install DB. So we need to run MySQL install _ DB. And then the next thing we want to do is called MySQL secure installation. And now let's see, the thing about the password is we need to install, the password, we need to make it a secure password. So let's go ahead and use the one that we created before. And you're not going to see it visible on the screen. Oops. Oh, we're just going to say enter for none. Okay, set root's password. Yes. Okay, the new password is that one. We want to remove anonymous users. Yes, we want to disable the test database. And reload privilege tables. Cool. And just for refresh purposes, that is our password. And we've now set up our MySQL. Now, the next thing we want to do is we've installed MySQL Python already. We want to do this on the other nodes. So the next thing we go to is the network node. And we do yum -y install MySQL -Python. And capitalization does matter. And I'm going to go ahead and copy this command, and we're going to paste it into the next area. Here's one thing to keep in mind. We need to save this password, so I've created this third display over here for general information that we don't want to lose. Okay, so we're back on the controller. Okay, we've installed MySQL Python on network, and we've installed it on the compute node. So the next thing we want to do is install the actual OpenStack packages. So on each node, we need to do the following. And we're going to actually type it out because it's going to take some practice. So yum install http repos.fedoraproject.org repos OpenStack OpenStack-icehouse RDO release icehouse-3.noarch. Actually, we are not going to copy these. We're going to copy these. Okay, so the first thing we do is we've set up, well, that's interesting. The repo is not working. They may have actually changed. Ah, it's Fedora people, not Fedora project. Well, that's an interesting little change there. I suppose the Fedora people and the Fedora project are two different things, and one is probably decentralized. So this could take a while. I'm going to go ahead and pause the recording. Okay, the next thing we're going to do is yum install. This is called Apple, which is extra packages for enterprise Linux. If we're running Fedora, we don't need this, but I'm running CentOS 6.5, which is a derivative of Red Hat. So this is actually from fedoraproject.org, pub apple 6x86 underscore 64 / apple release 6-8.noarch. And what this does is install an actual other repository. And if you're not familiar with yum, yum is Yellow Dog Update Method, and it's a great way to get software onto a Linux system. It's primarily RPM-based distributions, but you can get yum for Debian, apt-get install yum, and there's something called alien that's similar to RPM installation. So we've gone ahead and done that on the controller node. Let's go ahead and do the same 2 steps on the network node. And again, we're going to type this manually from the book, just to make sure, to get comfortable with this particular site. I'm going to save this in the buffer. We'll do this in parallel. So we're on the network node. We're going to do the same thing on the compute node. Go ahead and paste that in there. Is this okay? Yes. Like the network node, yes, it's okay. And again, these are just repository files, so it's not an actual software thing. What these will do is allow us to use yum to actually install OpenStack. Okay, so the next thing is yum install. Again, we have to install the Apple. Now we're on the network node. dl.fedoraproject.org pub apple 6x86 underscore 64 apple release 6.8 noarch.rpm. Let's go ahead and copy this to the buffer. Go ahead and press enter. Do the same thing on the compute node. Go back, it's going to prompt us, is this okay? Again, you can add the -y if you really trust that you're not making a typo. I make enough typos, and I find that when I'm root, I like being second-guessed by the computer. So here we go. So we've now installed the repos for OpenStack as well as Apple on all 3 nodes. So the next thing we're going to do is actually install OpenStack utils. And we're going to do this on each node, and we're going to install OpenStack SE Linux, and then we have to upgrade, and then we're going to actually reboot if it included a kernel package. So the next thing we do is the installation of the actual OpenStack utilities. And so to go ahead and do that, it's yum install OpenStack utils. And do that on each host, each node. By the way, we're on page 20 of the guide. So yum -y install OpenStack utils. And let's save this in our buffer. And we'll do the same thing over there and over there. So it's installing a whole bunch of stuff. These are actually GPG. GNU Privacy Guard, it's kind of like PGP. There are keys that authenticate the actual software. Okay, so we've installed this, and the name of that makes me think of databases. What is it? Create, remove, update, delete? I'm not sure. Something like CRUD, which has to do with databases. Okay, so the next thing we want to do is yum install OpenStack SE Linux. So yum -y install OpenStack SE Linux. Actually, before we do that, there's a warning. The OpenStack-config program in the OpenStack utils package uses crudini to manipulate configuration files. However, Crudini 0.3 does not support multi-valued option, and there's a bug instance. You can set multi-valued options. I don't really know what that means, and I've never encountered that with OpenStack. So let's go ahead and set up OpenStack-SE Linux. So we're going to do that as well. So yum -y install OpenStack. Let's spell it correctly. And let's save this command because we're going to run it in parallel on the other machines. And I don't actually know if this is going to update the kernel. It looks like it's doing a lot of stuff. So we will probably reboot each node. But we can tell for sure by looking at the software that gets installed. So it's installing lib SE Linux, SE Linux Python, SE Tools, which is SE Linux Security Enhanced Tools, more Python. Everybody likes Python. Lib C group, that has to do with kernel groups. Those are used for virtualized environments that are a little bit lighter weight container groups, and audit libraries. So we're going to go ahead and pause the recording while this runs. One of the things I've gone ahead and done is created this fourth window over here in case we need to run some other scripts. Again, general is just being used to save passwords and other things that aren't easy to remember. And this is just in case we need to run additional scripts that fall outside of the steps on each node. Okay, so the next thing we need to do is actually yum upgrade. So yum -y upgrade on each node. And this may require a reboot. It looks like the network node is finishing. And the compute node should probably be finishing too. That's actually a little bit beefier. It's got 4 cores. Okay. So we're running the upgrades in parallel. Looks like there's only 8 packages that are being upgraded. So we probably will not need a reboot because it looks like we're not updating the kernel, which is fantastic. So that'll save us a little bit of time. So let's make sure that that's the case on all things. So it looks like on the network node we only need to update IP route or install it. And on the compute node it's just a couple of Python things, which is fantastic. So hooray, no reboots. That's good. Now while this is running, the next thing we're going to do is install the messaging server. And it's QPID, which is we're going to use QPID, but you can also use RabbitMQ or ZeroMQ, and you can pretty much use any one of them. But we're going to use QPID on this particular system because we're using CentOS 5, and that's the one I know. Okay, so let's go ahead and do that. Yum -y install QPID-CPP server, and QPID is of course a message queue, message bus system. So let's go ahead and we're going to repeat this command on the other 2 VMs. So do that. And then once QPID is done, we've got to edit a config file. We're going to go ahead and start that up. And at this point, then we're going to install the actual OpenStack services. So that'll be the next component of this lesson. Right. And we're good. Okay, so we want to edit the qpidd.conf on each node and set auth equals to no. Okay, that's the last line on the file. And let's go ahead and start it. Okay, so we're going to do the same thing on the network node. And finally on the compute node. Fantastic. Oh, we actually have to probably restart it because we forgot to do the auth just now. So I'm going to just do service qpidd restart. Cool. Okay, so now we have qpidd. So now we're going to actually install OpenStack services.